Hi and welcome to another edition of Car Engineering Simplified. And today's video is the third video in a series on vehicle brakes. So let's get stuck in today's topic, the drum brake. As the name suggests, the system consists of two brake drums and two sets of brake shoes. If we look at one side and have a look at the components in the system, we can see we've got a backing plate that everything is mounted to. We have a wheel cylinder, we have a handbrake lever and a handbrake cable, 1, 2 retaining springs and 1, 2 retracting or return springs. Most importantly, we've got two brake shoes, a leading shoe and a trailing shoe. Now that is all down to the direction of rotation. In this instance, we're going to have the direction of rotation in a clockwise manner, but more of that in a minute. Let's start off by having a look at the wheel cylinder. This particular view of the wheel cylinder is from the back, and what we can see here are two mounting points for fixing it to the backing plate. We have a hole for the brake pipe to go into, and what we have here is a bleed nipple that allows us to get any air out of the system after we've worked on the brake system itself. If we were to cut open this wheel cylinder, it would look something like this. We can clearly see here a hole that allows the brake fluid to fill the void between these two pistons with a fluid seal on and a dust boot to protect the chrome finished surface of the wheel cylinder pistons. If we take a closer look at the wheel cylinder fluid seals, we would see that the actual edge of the seal isn't straight, it's slightly tapered, and the back edge of it is like the letter U. This would have the effect of, as fluid pressure pushes in this direction, it fills the void, swelling the seal out, forcing the edges against the wheel cylinder, and therefore making it nearly impossible for any fluid to come past the seal and leak out, contaminating the brake shoes and the brake drum. If we were to build all the components up of the brake drum, it'd look something like this. We have our backing plate, wheel cylinder, our leading and trailing brake shoe, retaining springs, retracting springs, our handbrake levers sticking out here, with our handbrake cable there. So what's exactly happening? As the driver presses the brake pedal, fluid pressure acts in the back of the wheel cylinder, forcing the two pistons out against the top edge of each brake shoe. This in turn pushes the brake shoe into the brake drum and starts to change all that kinetic energy into heat energy, therefore slowing the vehicle down. As we said, leading and trailing shoe, we've got a direction of rotation in a clockwise manner. It's not uncommon to see the leading brake shoe have more friction material than the trailing shoe because of something called a self-servo action. As the brake is activated and the rotating drum draws the leading shoe into the drum, increasing the force applied, and the trailing shoe is almost pushed away from the top edge of the brake drum. In the previous braking system overview video, we talked about the system having a front to back split of about 60-40, 70-30% in favour of the front brakes. Drum brakes, we can almost say the same for the leading and trailing shoe. The leading shoe takes the majority of the braking, 60%, 70%, whereas the trailing shoe takes less, 30-40%. This is why the leading shoe will have a larger friction material than the trailing shoe. If we take a look at the handbrake, we've just flipped everything upside down so we can see the mechanism more clearly. Our cable runs this way and the driver operates the handbrake lever, pulling the bottom edge of the handbrake lever in this direction. Acting on a pivot point, the top edge of this brake shoe is pushed out into the drum, and this part of the lever acts on this rod, pushing everything in that direction, moving this brake shoe out into the drum. Don't forget down the bottom here, these are a fixed anchor point. If we look at our brake drums itself, they come in many shapes and sizes, generally made of cast iron, cast aluminium. Some may have cooling fins on them, some may have plain face on them. But generally speaking, we need to ensure that the braking surface inside here, just like a brake disc, is of good quality, rust free, pitted free. It's not cracking under extreme heat. We could see that by having almost a rainbow effect coming through the metal, and the brake shoe material itself hasn't damaged or worn away and caused ovality of the brake drum. Okay, I hope you've enjoyed this video on drum brakes. Don't forget to check out the other videos on the overview of the system and disc brakes. Give it a thumbs up, pop any questions and comments down below, and don't forget to subscribe for new videos coming soon. Thanks very much for watching.